Good morning and welcome back. Today we are going to begin talking about how we can graph lines and circles. Okay, so if we are given something, this will be in polar coordinates. So for example, if we were given theta equals pi over 4, we can figure out how to graph this on our graph. Now, if we look here, you might notice there are more marks than we are used to. We are used to these marks right here, 3 in the middle. We're not used to the one closest to each of the axes. Okay, so let's talk. We know that originally this is pi over 6, this one's pi over 4, and this one is pi over 3. We could go around the whole circle and do that. However, we don't have what these two marks are here in this first quadrant. If we think about it though, 1/2 of the circle is pi. So if we count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There'd be 12 intervals evenly that would get us to pi over here. So what that tells us is that this first one would be pi over 12. Likewise, 1, 2, 3, 4, 5. This one up here will be 5 pi over 12. Okay, as we go across, we get 7 pi over 12. And right here would be 11 pi over 12. I'm not going to fill in all the information. You could if you wanted, but I'm just going to fill in the new ones. So down here then, we're just past, so that's going to be 13 pi over 12. Oops. Down here we'll have 17 pi over 12. 19 pi over 12, and the final one right before we finish at 0 or at 2 pi, it's going to be 23 pi over 12. Now it is up to you if you want on your unit circle. Some of you might find it beneficial to go in here and kind of put a dotted line here and put the mark pi over 12. If you want to do this, you can. If you don't think this is worth your time or it's helpful to you, you don't have to. Remember we said that'd be 5 pi over 12, 7 pi over 12. Okay, you could keep doing this all the way around, fill in each of those. Once again, it's up to you if you want to, but if you'd like to, that might be helpful to some of you, just so you remember those exist. Now, back to the problem at hand. So this problem, pi over 4. If we think about it, pi over 4 is right here. If I was trying to get a theta of pi over 4, the radius could be 1. If that's the case, it'd be right here. Could be 2, could be 3, could be 4, 5, 6, 7, 8. It could be 0. It could be -1. Okay, it could start working back the other way. It could be -2, -3, -4, -5. You might notice a line starts to form. Okay, if we fill that in, that will be our answer here. This red, what I put, this one is just going to be a line. Each of the points on that line would have a theta of pi over 4. Now, if it's this way, it'd have a positive radius. If it's this way, it'd have a negative radius. But we could graph each point on this line if it had a theta of pi over 4. So likewise, on the next one, to get theta of 5 pi over 3, all we have to do is find where 5 pi over 3 is. So we look at our, if we forget, we can look at our circle down here in quadrant 4. Now be careful, there's that extra line on here. The reason we have these, also Delta Math has these extra lines on this assignment, so I wanted you to be aware of it. So right here, this one is 5 pi over 3. And if we think then, that means any point. Oops, that did not work. Let me fix that. There we go. Any point along that line, I need to add arrows to both ends, would be 5 pi over 3. And that is the case if we are given a theta only. Now, if we are given just an r, this will be different. This is saying the radius is 3. We know that the radius is 3, so everywhere that the radius is 3 is an option. So if we start at the center, out 1, 2, 3, anywhere around this edge, there's already a circle there. I can just trace it because anywhere around that is a radius of 3. Now, obviously, my circle is not perfect. Maybe I could use this and let's see, I could make it a little, oops. There, that's a little better right there. Okay, let me change the color for the next one. Radius of 7. So if I start here and put it there, that will be a radius of 7 because every spot on this is 7 away in a different direction from the center. Okay, so both of these, we maybe need to make a point. If it's just r equals, that's going to be a circle. Where if it is theta equals, it will be a line. Okay, now, these are centered around the origin. Those are pretty easy to graph. Sometimes it will not be like that. If we look here on the back, we have r equals 4 sine of theta. Okay, now, it is our job to figure out where this is, and I have a table for us. We're going to graph it one time with the table. It's a little tedious, but then I'll show you guys a shortcut and how we can do it. So if we look here, theta, we want to know what values are nice for theta. We want to make this as easy on ourselves as possible. So to do that, if we think back to what values of theta we could plug in for sine that will give us a nice number to deal with. What I mean by that is if I plug in, say, pi over 4. If I plug that in for sine of pi over 4 is square root of 2 over 2. That's not that nice to work with. We want to know when is sine either 0, half, or 1 because those are easy numbers to deal with. It's right here at 0, at pi over 6. Neither of these is very nice. They have a square root. Up at the top here at pi over 2, it's 1 again. Okay, not very nice, not very nice. Over here at 5 pi over 6, it's nice again. At pi, it's 0. That's nice to work with. Okay, as you can see, here it's nice to work with. Square root, square root. Nice to work with. Square root, square root. Nice to work with. Okay, so we want to use the ones that are nice to work with. And those values for sine, it's not the same for cosine, but for sine, those values that are nice to work with would be 0, pi over 6, pi over 2, 5 pi over 6, pi, 7 pi over 6, 3 pi over 2, and 11 pi over 6. All right, so now, in order to figure out what the r is, we can just plug in these values of theta and solve. So if we think about it, for this first one, it'd be 4 times the sine of theta. Sorry, not the sine of theta. It is 4 times the sine of theta, but we already knew that. 4 times the sine of 0. And we'll see what that gets. Now, if we think the sine of 0, over here, sine of 0 is 0. So 4 times 0 gives us a 0. So when the radius is 0, or when theta is 0, the radius is also 0. So that's going to be right at the origin there. Nice point there. Okay, now our next one. 4 times the sine of pi over 6. So we look at sine of pi over 6 right here, that's 1/2. So we would have 4 times 1/2. On that first one, it was 4 times 0, which gave us 0. 4 times 1/2 we know is 2. So pi over 6, be careful, that's 2 spots now. And out 2. And right there, that is where it would be at. Okay, now our next one, pi over 2. Okay, so pi over 2, 4 times the sine of pi over 2. And this will occur, so 4 times, now the sine of pi over 2, we go up here, sine of pi over 2 is 1. So 4 times 1, you know, is 4. So at pi over 2, that's a quarter turn, and up 4. 1, 2, 3, 4. Next one, 4 sine of 5 pi over 6. So 4 times, now if we look here, 5 pi over 6, sine is 1/2 again. So 4 times 1/2 gives us 2. 5 pi over 6 is around over to here and out 2. Okay. So it's symmetrical, as you can see, across the y-axis, which hopefully makes sense because we have a sine here. Okay, now we can keep going, and we'll do it for these last 4. So 4 sine of pi, we need to find that. We need to find 4 sine of 7 pi over 6. We need to find 4 sine of 3 pi over 2. And then we need to find 4 sine of 11 pi over 6. So 4 sine of pi. At pi, the sign is 0. So 4 times 0 is just 0. You'll notice we already have that point on our graph, so I don't need to put it again. It's already there. Our next one, 7 pi over 6. Let's go to 7 pi over 6 here. That's negative half. So 4 times negative half, that'll give us negative 2. So we go to 7 pi over 6, which is over here, but then it's negative 2. So back 2, and oh, look at that. We already have that point as well. 3 pi over 2. So on this one, it is negative 1. That will give us a negative 4. But look at that. If 3 pi over 2 is down here, but negative 4 up 1, 2, 3, 4, it's the same spot we already have. So I'm guessing you can guess on this last one. Once again, negative 2, 11 pi over 6 is over here. But we go back 1, 2, and right there. And as you can see, we already have it. Now, to get through all those points, this is actually a circle. And I didn't draw it perfectly. I'm a little low, but as you can see, that circle goes through all of those. If you want, you can put the center of it. We know the center will be at 2. Oops, let me change that. So the center there at 2. Okay. And that will always be the case when we have something in this form, r equals 4 sine theta, or r equals negative 2 cosine theta. Now, let's talk about a shortcut here, because that did take kind of a lot of time. You'll see they started to duplicate. They repeated on each other. So essentially, the circle goes around twice. We only need it once. We can figure out a shortcut. So first thing we want to notice here on this one, it's cosine. Okay, if it's cosine, then that tells us that we know it's going to be on the x-axis. It's symmetric over the x-axis. Okay, next, it is negative. We know negative on the x-axis means go to the left. So from the origin, it'll go to the left. Now our next one, we want to know what is the diameter. This is pretty easy. Hopefully you can tell. Let's look at the last one to figure this out. On the last one, our diameter, 1, 2, 3, 4. See this 4 up here? Now our diameter, some of you might be tempted to say negative 2. A diameter is a distance, so it has to be 2. And then finally, some of you might find this helpful when drawing it. That means the radius is 1. So if we think about it, if it starts on the x-axis to the left, so we can put a point at the origin, it goes to the left 2 with a radius of 1. So there's the center point. Let me switch back to my circle to help me draw this. So if I start in the middle, and there we go. I'm off a little bit. I think I'm a little too high, but pretty good circle. Okay. So using that same method, let's use our shortcut. So this one will be symmetrical. We have the keyword sine here. It's symmetrical over sine, so that's the y-axis. Once again, it's negative, so that means it's going to be down. It is going to have a diameter. I'll just put d of 5, which means the radius is half of that, 2.5. Okay, so it goes down. So it starts here at 0, down 1, 2.5. That's where the center will be. Down another half, and then 2 more for 5 total. That's where the circle will end. Okay, so once again, look something like that. And our final one for the day. Okay, so once again, cosine. So that means it's going to be symmetric over the x-axis. Cosine is associated with x. This time it's positive, which means it will go, oops, I almost put up. It's not going to go up, it's going to go to the right. The diameter is going to be 7. Radius is always half of that, so 3.5. So it starts at 0, goes to the right, 1, 2, 3.5. That's the center of the circle. And out here to 7, that's where it will end. I'm going to go ahead and sketch that in. All right, and we are done. Now, obviously, your circles won't be perfect when you draw it in. Just do your best. I use this kind of cheated to help. If your circle, like if I look at this one, if I redo this by hand, so maybe my circle, just try your best to make that center point the center. So by hand, it's not quite as perfect. When you graph it on Delta Math, it'll have a circle button that will help you. So go ahead, sign into Delta Math, do some circles and lines, get that done. If you have any questions, please let me know, and hope you guys have a great day.